Alright guys, so I'm back with another video. It's been a while. I had somebody request that I show them this occlusion. So I'm going to show you guys how to make that, and I'm going to explain it to you. Um, so anyway, let's get started. Over here in this project, I've already recreated it. I did it a little bit differently than the video that I followed. Which the video that I followed, it didn't show you how to fix the issue with the shadows, because this does mess up shadows. You have to add an extra node that prevents it from messing up the shadows. Anyway, yeah, so I'm going to fully explain this. The guy in the Russian video, I'll put a link down to his video in the description. He doesn't go into detail on all the math and what's going on here. I'm going to go into all the math and explain to you guys like why he's doing stuff like this, 1 minus, and adding and multiplying. You're going to understand this after I'm done explaining it to you. So first off, I want to point some things out. You'll see that between these two objects right here, that it looks different. So I'm going to explain to you right now why, and you'll notice I have my modeling mode open, and that's because this one right here is the same mesh as this one right here, but I messed with the UVs so that it looks correct. So basically, this box right here was actually this one right here, and I just put that mesh, that material on it. And this is one of the cubes that comes with the level of prototyping, starter content stuff. So it has bad UV scaling. So if you ever notice this being too smooth, or looking the tiling looking different on this pattern here, then that's why. It's because your UVs, your UV tiling is either scaled up higher or scaled down too much. So you'll have to try to make sure that the UV tiling is scaled proportionally across your models. For the most case, this shouldn't be a problem. In this case, it was. I'll go ahead and show you how to fix it though. If you want to fix it, you can come over here to project UVs. This is just a quick hack. It's not the proper way to do UVs, and this will probably actually give you really bad UVs. It might look good in most cases, but in some cases it might actually cause problems with your UVs. But for the most part, it's a quick and easy way to fix UVs, and you'll see already that just with this preview open, the UVs are already scaled properly. Yeah, keep that in mind. This is mostly because of the settings that I put in here. You can mess around with them if you need to, but I think what I normally do is I'll auto fit it, and if it's still too big, I'll put it up next to something else, and I'll mess with it until it looks like it's about the same proportions. So anyway, let's go ahead and get started on this. You'll notice that these are still casting shadows underneath them, even though that it's opaque. I'll go ahead and show you what I'm doing there. So that's basically just a shadow pass switch. One means the shadow is on where it's occluded. So you'll just enter your occlusion here into the default, and under the shadow, you could enter a mask. There are videos on that where you could give something the shadow of a person, even though it's a box, you know. Anyway, so with that being said, let's just go ahead and get started. First off, we're going to make this as a material function, as you can see here. This allows us to add it easily into other things. So you'll just create a folder if you want, and we will name this folder whatever. But the important thing is to right click inside of here and go to material and go to material function. I normally use mf underscore for my material functions, and then you can call it occlusion, masking, or whatever you want to call it. And then what we'll do, this will allow us to easily drag and drop it into materials and hook it up. So most of the materials are going to be opaque. You're going to want to switch those materials by selecting this right here and setting the blend mode from opaque to masked. Keep that in mind. I'll walk you through it here in a minute. But the first thing we're going to do is we need to get the world position of the pixels on the texture, because we need to know if how far away the pixel is from the screen, and we'll also be using this data for some other things too. So normally the world position is going to be in world coordinates, and so we need to transform this from world space. And if you have this transform vector selected, and I did that a little bit fast, but you just type in transform and you'll see under vector ops, you'll see transform. Select that one, and now go down to source, and this is world space. So the source of this is world space, and we want this to be in view space. So view space is what you're viewing right here. Everything that you see on the screen right here is in view space, and so that's what we want. We want everything to be in view space so that it's relative to the camera. So another thing we're going to do the same thing for the camera position. So we're going to get the camera position WS right here under coordinates, and we're going to do the same thing to it. We're going to do a transform, and don't forget to change the source to world space, because the camera position will be in world space and we need it to be in view space. So with that out of the way, the next thing we're going to do is we're going to create a sphere mask, and what this will do is it'll get that view space and it'll draw a sphere on that view space. So we're going to get a sphere mask, and that's under utility. And for A, that's going to be the pixel location of the texture on the material, the pixel location in real world space. But in this case, because we're getting the camera position and we're getting the world position, the reason why we plug the camera position into B is because B is where the sphere is going to be centered at. So what this is doing is it's drawing a sphere in view space, and its origin, the origin of that sphere, is going to be the location of the camera. So 0, 0, 0 of the view space will be where the sphere is residing at. And now the texture space is A, and so that A is what we're going to be drawing our sphere onto, and that's going to be the pixels of this texture, the pixel locations of this texture relative to this camera position, or the view space, since we converted both of these into view space. So anyway, you can set your radius by holding down 1 and pressing anywhere on here. That'll create a parameter. You can right click and convert this to a parameter, and you can call this radius. Also, this is called a scalar parameter, so you could manually do it like this. Under your parameters, you can find scalar parameter, and we'll call this one a hardness. Now, I found that a good default value for this was probably about 0.5 for hardness. Hardness, it basically kind of fades out the sphere around the edges. So you can play with that value if you want. Radius, I'm just going to give it a radius of 500. That seemed to work for me for most cases. So you'll be able to play with this in the material instance that you create of whatever when you apply that to things. Now, what this sphere mask is going to output, it's going to output a texture where the sphere will be opaque and everything else on the texture that isn't inside of the sphere will be transparent. So what we need to do is, because we need to invert that, we're going to do a 1 minus, and that will invert that, and now everything inside of the sphere will be transparent and everything outside of it will be opaque. So in this case, because this is an opacity mask, 1 means fully opaque, means fully visible, and 0 means fully transparent. And so what we're doing here is we're making all the values inside of the sphere, we're making that 0, and we're making everything else outside of the sphere 1. So if you can visualize that. So now what we're going to do is we are going to add a texture to this mask. And what this will do is if we use a grayscale texture, like a cloud, if you can imagine the cloud textures, in fact, I'll go ahead and show you. We're going to create a texture sample parameter 2D, because we want to be able to swap this texture out from our material instances. And we're going to call this the mask pattern, and we're just going to use the red off of this, and it doesn't really matter. I guess you could use the red, the green, or the blue, but the value that it expects right here, I believe, is just a single channel. It expects a single channel. You could probably do the whole thing, but anyway, that's actually one part of it. I didn't actually research that much, but just like the red channel, or the green or the blue, but the red channel, I believe, will work just as good as any. So anyway, we're going to pan this texture so that it's moving. It'll make it appear animated. So in order to do that, we need the texture coordinates, and that's just needed for the panner. So we're going to get a panner here, and the panner requires the coordinates because it needs to know where it's at. You'll see that the texture coordinate outputs the UV texture coordinates in the form of a 2-channel vector value, allowing materials to use different UV channels, specifying tiling and other operations on the UV. Right, so it's just a coordinate for the texture. So we're going to plug that in there. Now this guy added a multiply, or you can hold down the M on your keyboard and click. He added a multiply for in order to control the power of the panner. You can do that if you want. You don't have to, but if you do, I'm going to call mine pan power, and I'm just going to plug this in here, and I'm going to give it a default value of 1, because 1 means that it isn't actually going to change it, but if we want to, it's the value is there if we want to change that power. Now for the speed, we'll get the pan speed, and again we're just making another scalar vector parameter, and we're plugging it into the speed. And 0.1 is fairly fast, but it'll probably work. If you want, you can turn the value up in order to slow it down. So yeah, I believe. So we also want to be able to control the UV tiling of this mask. If you don't want to, then don't worry about this part. In fact, the pan power is actually going to work probably about the same as that would. But I'm going to go ahead and I'm going to go ahead and do that. So we're going to do another scalar parameter. Oh, let me just hold down 1, and I'm going to multiply this again, and this will be our tiling. So you could do that, and in fact that's almost probably redundant. You could probably just use the pan power to tile it. I think that would probably have the same effect, but I'm going to set the tiling to 1 by default. And so now what we have is, let's switch this over to a noise texture, and we'll just choose this tiling noise 5 that comes with the starter kit. Or it's a part of the engine actually. So we'll choose that one. And now if the sphere inside of the texture, if that sphere is 0 for transparent, in other words not opaque, then it's black. What that means is that any black points on this that we add to that will stay black, but any white that we add to that black will turn white. And so what that'll do is it'll destroy our sphere mask. It'll create the pattern in form of transparent versus non-transparent, depending on where it's white and where it's black inside of this mask. And so in order to fix that, we need to multiply this back into here. And the reason why this works is because, remember, those values in the center where the sphere is, the transparent parts are black. They're 0. And so when you multiply any value by 0, you get 0. So any number multiplied by 0 equals 0. And so what happens is where it's solid black on that sphere mask, it'll turn it back to black. But where this pattern is around the edges, where it's soft, that part will retain this pattern. So that's how that works. Okay. Now what we need to do is we need to test for the distance of the pixel from the camera. So in order to do that, we need to get the offset between this vector and this vector. So how you do that is you subtract. So if we subtract the camera position from the absolute world position of that pixel, then we get the difference. And then we can use the distance. If you right click and just type in distance and then scroll down to utility, you'll see distance here. Just click it. And now what we're going to do is we're going to plug A into distance. And so we want to know what the distance is of this difference vector is from the origin. So the origin obviously is going to be 0. So just hold down 1 and left click, and that'll give you this value right here. And so 0 represents the origin, and you can move your mouse over until you see this bubble, and then you can click it and you can type in origin if you want. And you can label all this stuff as I describe it, such as this. You could distance from difference vector to origin. You could do that if you want. It's up to you. Anyway, so now what we need to do is we need to create another scalar vector or scalar parameter, and we'll convert that into that scalar vector into a parameter, and we'll call this distance. So this is the max distance from the camera that we want the pixel to be before it is occluded. And so I find that a default value of about 1500 seems to work. Now, how do we put all this together? We need an if statement. So we'll say if the distance, and you can actually label this something else like max distance so that it's obvious what it is. So if the max distance and then the distance, so if the max distance is greater than the distance, then we want it to be transparent, meaning that they're close to this sphere that's drawn around the camera. So we're going to get this multiply right here, and we're going to plug that in there, and you can double click this and plug the other one into the equal, because if A is greater than or equal to the actual distance of the pixel from the camera, then we want it to be transparent. We're going to hold down 3 now and left click on the keyboard or left click on the mouse, and we're going to change this color to just solid white, because solid white represents opaque, remember? So we're going to, if the max distance is less than the distance, then that means that pixel is further away from the camera than what we want to be transparent, and so we want that to be opaque. And so we'll plug that into the output, and yours might be black, or it might be this. Okay, yeah, it'll be white like that, but when you zoom in close enough, it'll be black. So if it isn't, it's probably one of these values over here, probably the radius or the distance value. But anyway, so if you did everything correct, then this should be ready to plug into something. And so we can create a material, and I'm just going to create a new material, and I'm going to call this test masking. And I'm going to open this up, and with this selected, I'm going to go down to blend mode. I'm going to make this masked, and then I'm going to drag my material function into here, and I'm going to get my shadow pass switch, and then I'm going to plug that into opacity. It needs a value, so I'm going to hold down 1 to create a scalar vector, and I'm going to set this value to 1. That way it knows to draw the shadow regardless. So now I'm just going to create a color here, and maybe I'll set it to something like red, and I'll use that as the base color. And so now if we did this correctly, then Yeah, looks like we did it correctly, but there seems to be a problem with these values that I'm using. So I'm going to create a material instance of this. I like to do mine like this. MI testing mask as a material instance. And then I'll assign that to it. And then I'll open it. And maybe this needs to be higher. So in this case, maybe it needs to be 2500. Alright, yeah, sorry about that. So I did forget something here. I forgot to mask out the transform vectors. Now, because we're working in view space, we're not working in world space, we do have to mask out the Y, because if we don't, then what ends up happening is this sphere mask may get placed somewhere above the viewport to where it is never visible on the screen because it's being drawn off screen. Yeah, so that's why that's the case. So all we have to do to fix that is off this transform vector, we're going to get a component mask. You'll see under here, under math, select the component mask and just leave it as it is, RNG. RNG in case of coordinates, R stands for X and G stands for Y and B stands for Z. So yeah, so just plug a mask between these and then save and apply it, and it should be black. I thought something was up when it wasn't solid black from the distance that I was earlier, but for whatever reason I just kind of ignored it. But if you zoom out real slowly, it should do this now. So with that out of the way, we can go over here to this. 1500 will probably be okay, like I had done originally. But if you want it to be visible from further away, you'll see you might want to actually, well, depending on how far you want your camera away to be away from the character, you're going to want to adjust this either way. So maybe 2500 would be good, or maybe you want it to be even further away. So we could turn that up to 4000, and you'll see that even from this distance. Also, you can adjust the tiling of this now, so that you can adjust that to make it look more visible from whatever range. In this case, I'm tiling it up. You could also tile it down, but that's up to you. The hardness will probably play a role in this. So if we set this to something like 4, and we set this to, let's say, try 0.1, then it might show up a little bit better. But it'll make the sphere smaller. So you might have to turn this up higher. No? Okay. You would have to turn up the radius. So that's how that works. So there you go, guys. Let me know down in the comments if you have any questions, what you thought about this, or whatever else. And I'll see you guys in the next video.